Okay, so this is section 9.3. This is going to be example 3, and we're going to graph a rational function. So again, first step when we graph a rational function is to factor the top and bottom. And the bottom's not going to factor, we're just going to have an x minus 2. So when we factor the top, it's going to be a square minus a square, so that's a difference of 2 squares. So square root of x squared is x, square root of 4 is 2, and it's 1 plus and 1 minus. That way when you FOIL it back together, your middle terms cancel out. From here, you should see that this x minus 2 and this x minus 2 are going to cancel out. And when we cancel out, if you go back and remember from our vocab, when we cancel them out, we are disjointed, discontinuity, and we have a hole in our graph. So we're looking for our hole. And our hole will happen, when x minus 2 is equal to 0, because you can't have a 0 in the denominator. So x equals 2 is our hole. So x equals 2. So somewhere in here, we will have a hole. So once I cancel out the x minus 2's, then I just have left basically y equals x plus 2. And if I have x plus 2, that's going to be a line. The y-intercept is going to be 2. The slope is going to be 1. There's my hole. And then I can draw my line. Up to my hole, and then past my hole. To test our points, to make sure I'm doing this right, we've got our x and we've got our y. So what happens at 0? Well, if I fill 0 into my original function, that's going to be 0 squared minus 4 is a minus 4. And 0 minus 2 is minus 2. That's going to make it 2. Okay? That works out well. If I fill in a 1, 1 squared is 1. Minus 4 is a negative 3. And 1 minus 2 is a negative 1. So you get a positive 3 because 2 negatives make a positive. And there I am at 3. So that worked. At 4, or at 2, at 2, that's where our hole should be. So let's double check that. 2 squared is 4. That's going to be 4 minus 4. And 2 minus 2 is going to be 0. So you got 0 over 0. Can't have 0 in the denominator. So that's undefined. Let me go one beyond that to make sure that we're okay that direction. In my positive direction to the right. So if I try a 3, 3 squared is 9. 9 minus 4 is 5. And 3 minus 2 is 1, so that's going to be a 5. And my point right there is the point 3, 5. Oh, let's go the other direction, and let's check our negative. So if I put a negative 1 in there, negative 1 squared is a positive 1. And 1 minus 4 is going to be a negative 3. And then negative 1 minus 2 is going to be a negative 3. And negative 3 over negative 3 is a 1. So at negative 1, I'm at 1. Let's check negative 2. So negative 2 squared is 4. 4 minus 4. And then I've got negative 2 and minus 2. So that's going to be a 0 over negative 4. So that is 0. And you can see that my points are going to line up on that line. And I could keep checking more if I wanted to. I can check halves. I could check 1.5. I could check 2.5 to see if what's happening is I'm getting closer and closer to that 0 point. You can put it in your calculator and see when you graph this thing, it's going to graph and not look like there's a hole at all. Because again, points are so tiny that you can't see them. So when you graph every point except for one point, it doesn't look like there's a hole at all.